Hello guys, this is Matt Dean with A+ College Ready, and today I want to talk to you about the Labquest 2 and the Labquest 2 viewer software. If you're an A+ program school teacher in cohort 13 or an ITIP teacher, you're going to receive a bundle of 6 Labquest 2 interfaces with an assortment of probes. You're also going to get a copy of the Labquest viewer software. So first we're going to talk about using the viewer software and how to connect it to your actual Labquest 2 device. First thing that you have to do is to make sure that your computer and your Labquest 2 are on the same Wi-Fi network. So to check that, you're going to go to your Labquest 2 and hit the home button. And you're going to go to connections, and you can see that right here. Here's where you check your connection. Mine is on Matt's iPhone network. If you need to change that, click on this little gear, and you can connect to whatever available network there is. Simply make sure that your computer and your software are on the same network. If they are, all you're going to need to do is that when your software comes up, let's close the software for a second and show you that. So your software, when you install it, is going to be under Vernier, which is the company that makes it, Vernier software, Labquest Viewer. It'll take it a second, but it's going to search for Labquest that are on the same network. Since there's only one, that's the only one that's going to show. Now, if you're in a classroom, you might see a bunch of different ones, so you need to figure out which one is the one you need to connect to. Right now, this is the only one. To connect to it, I simply click on it. Double click. So now I have my Labquest. From the computer, I can now control the Labquest device. Now, this Labquest device will do all kinds of cool things. First thing that I want to do is to set it up to do the Catalase Lab. We're going to do a demo of the Catalase Lab in a minute. Before we do, normally in an APSI like this, we would do at least 3 labs using the Labquest 2. We would do a Catalase Lab. We would do a photosynthesis lab with an indicator, DPIP indicator, and we'd also do some kind of type of cell respiration lab. Usually it's either with peas or with crickets. Today though, we're going to do the setup for the Catalase Lab. To do that, we're going to set both the rate and the duration. Before I do anything though, I need to plug in my gas pressure probe, which is the device we're going to use for today's lab. So I'm going to plug that in to my interface. Notice that it automatically knows that I have a gas pressure probe plugged in and that I have it plugged in and set for kilopascals. I can change those units if I need to, but for right now, I'm going to set the rate. To do that, I'm simply going to click on the rate box. Now notice I have rate and interval. I can set how many samples I want per second or how many seconds I want per sample. Well, in this case, I want to take a sample every 5 seconds. So I'm going to just type 5 seconds per sample. Click done. And for this Catalase Lab, you want to run a very short duration because you're going to be building up pressure in your bottle. So I'm only going to run this for, I'm going to run it for 45 seconds. Click done. I can go ahead and click OK on there. Now, if I wanted to go in and change units, as you saw what I did just there, I simply clicked on the unit, and I can go in and change the units to millimeters of mercury, inches of mercury, PSIs, ATMs, and so on. I think I'm going to set it on ATMs for right now. Notice it automatically went there. So now I'm going to be ready to take some data in a minute. Before I do, one other thing that I'll mention here, as our data is taken, we can click on this XY chart. We'll be able to see our data in a graph, in a chart, time, pressure. We also in real time can see a graph by clicking on the graph icon, or we can click on the sensor icon and just see live pressure, the live pressure reading at the time. So guys, now you can see my actual device setup. So here's my Labquest 2 unit. Here's my gas pressure sensor. Notice I have the small stopper connected. There's also a large stopper connection that you can use. I'm using this one because of the container that I had to use in this case. I'm not in the lab, so I had to use a makeshift container. My container in this case is just going to be a hand sanitizer bottle. But your container does need to be something hard. It needs to be either glass or plastic. I prefer hard plastic when possible. So to do the lab, first thing you need is a Catalase Source. Now, catalase is an enzyme that will catalyze the breakdown of hydrogen peroxide into water and oxygen gas. It's found in pretty much all plants and animals. I will tell you, this lab will work better if you'll get a purified source of catalase. You can order purified catalase from Carolina Biological. You'll get better results if you use a purified source like that, so you know the concentration. In this case, due to the quarantine, I don't have access to a purified source, so I'm going to use just a couple of chunks of potato. The way the Catalase Lab is written up, it's set up to be an inquiry type lab, where students can manipulate variables, environmental variables, and see what effect those variables have on the rate of catalase catalyzed reactions, the catalyzed breakdown of hydrogen peroxide into water and oxygen gas. So in this case, I'm just using a couple of pieces of potato as my source, so that's not going to be very standard. What's going to happen here, though, is that the enzymes in these crushed potatoes are going to cause the breakdown of hydrogen peroxide. One of the breakdown products is going to be oxygen gas. I'm going to have this container stoppered. So oxygen gas is going to start to build up in the container, and it's going to build up pressure. The more pressure, that should tell me that the faster the reaction is happening, the faster the breakdown of peroxide is happening. So essentially, we're using increases in pressure as a way to estimate the rate of the reaction. More pressure equals a faster reaction. Now, I will tell you, you don't want to run this reaction for very long, because if you do, enough pressure will build up in this container to pop the stopper out, and sometimes it can come out pretty forcefully. It could hit someone in an eye. So you do want to wear goggles. You want to make sure that your original container doesn't have any kind of cracks or anything. And you only want to run the experiment for 30 to 45 seconds and then remove the stopper once you're finished. All right, so we're going to set this thing up to run. I'm going to change views here in a minute. First thing that I want to do, though, is I'm going to pour in a little bit of hydrogen peroxide. Obviously, if you were doing a lab on this, you would want to use a known amount. I'm going to pour in just a little hydrogen peroxide, get this reaction going. Very gently shake, stopper, and then I'm going to hit go. I'm going to hit the go button on my Labquest, which is right here. And now I'm going to switch back to the Labquest viewer so you can see the changes that are happening. So now we're back on the Labquest viewer software. Here's my XY chart. And notice that we are slowly getting some changes in pressure. So we'll let it run out for the 45 seconds. Notice the pressure is constantly going up. It's going up in pretty even increments. Once that timer runs out, 45 seconds, the Labquest will automatically stop collecting data. I'm going to go ahead and remove the stopper from my bottle so we don't pop it out. And the Labquest, even though it gives you the data here, it'll do some analysis as well. We can click on the graph icon. You can see right here. It will automatically graph the data. It will also do some statistics for us. If we would like to do that, we could go to Analyze. Actually, let's look at the graph menu first. So we can scale the data. There's some options under Show Different Kinds of Graphs. What I really want to do, though, let's look at graph options first. So notice we can change axes. There's lots of different things we can move around on here. In this case, I think we've got them the way we want them. Let's go to Analyze. We could do a curve fit. And essentially the curve fit that you're going to want to do probably is a linear kind of curve fit, like a best fit kind of line. So essentially it's going to do a linear regression for you. And it will tell you the slope of your line. So right here's the slope of our line, which essentially is giving us an estimate of the rate of our reaction. And the rate in this case would be an increase of ATMs per unit of time. So that's about as complicated in a biology class as you would want to go. You would want to use the chart, the graph, and analyze function, curve fit. You can also look at some statistics. So if you just choose statistics, click pressure, notice you can get the minimum, the maximum, the mean, the standard deviation, the number of samples, the change in Y, the change in X. So some pretty meaningful statistics as well. But essentially that's showing you how to hook your Labquest 2 up to the Labquest viewer, how to do some basic setup of the Labquest 2, and then how to use the graph and chart functions. All right, hope that helped.